Right, this short session is on vibration, but it's specifically to do with transmissibility. One of the formulas that we're going to come across in terms of vibration control is one to do with transmissibility, and it's one linked to something called vibration isolation. So T in this case represents the amount of transmission of vibration from source to reception. And it's basically a function of the driving frequency of the vibration and of the resonant frequency of the mass spring system. So in this particular case, there are two expressions that we can use. The first one that I'm writing down basically has this formula where the F of F0 squared is taken away from the 1. This is for situations where the F is greater than F0. So in this particular formula here, the F0 is the resonant frequency or natural frequency of the system, and F is the driving frequency. The other formula that you can have, okay, is when F is less than F0, and the only real difference with this is that the transmissibility this time is 1 minus F over F0 squared. Okay? To know why there's a difference, you need to have a look at the notes and look at the lecture notes that I cover to explain that in a bit more detail. In this particular tutorial, I'm going to take this first formula, and what we're going to do is look at rearranging that formula for F0. Again, I'm doing this because this is a very, very popular exam question in both the general acoustics paper and the noise control paper. So it's a particular important maths to do. So we're going to use this formula here, okay, and we're going to rearrange that formula for F0, which is the natural frequency of the source. So first thing to do is I'm going to take this term here and put it to the top, and take the T and put that at the bottom. So the first stage is to end up with F of F0 squared minus 1 equals 1 divided by T. So all I've done is switch these two terms. Okay, that's all we've done now. So we've got the F0, it's tied in here. There's a minus 1 there. Well, let's just basically take that minus 1 across, and it becomes plus 1 on this side. Okay, so we end up with that. We might as well now square this out. So this becomes F squared over F0 squared equals all that. Okay, so we've just squared that out. The F0 squared is tied up in the division sum here. So what we can do now, I'll put a bracket round that, because I'm going to switch these two terms around. So the F squared stays where it is. The F0 squared goes to the top. And this term here, the 1 over T plus 1, goes to the bottom. Now when you get to that stage, you've probably already keyed in some numbers into the formula. So this particular denominator here won't look as clumsy as what it is here. Okay, so you've probably given the T value, and that will be a single figure. To make this into simply F0, we just take the square root of this term. Okay, so basically all we do is square root both sides and we end up with that. So as I said, this is a very common manipulation that you need to do, particularly in the exam situation. The other thing that you often have to do is to rearrange it for F as well. Okay, so again, it's a similar process, but obviously we go our separate ways when we get to this stage here. Okay, so that concludes that brief tutorial.